Alright everyone, so this is after us taking our practice final exam. These are the practice final exam solutions for a little bit of extra credit. So let's get into it. Find the volume of the solid generated by revolving the region bounded by the curves f of x equals square root of x, g of x equals x squared, about y equals 1. Just to save a little bit of time, I did write a couple of things out here. So I wrote down the formula that we're going to be using, as well as off to the top right side here. I found our limits. So to find the limits, you just set the equations equal to each other, find your x values. Our point of intersection after finding our limits, 1 over 1. And draw a first function here in a different color. That's a bad one. That's a good one. More or less is a rough sketch. Square root of x. Use a nice purple. This will be our x squared. Okay. From here, we're going to draw two arrows that designate our inside and our outside function. The smaller arrow is our inside function. Larger arrow is our outside function. Okay, we're going to be rotating about this y equals 1. Keep that in mind. So, from 0 to 1, our outside function, since we're rotating around the 1 minus x squared squared minus 1 minus square root of x squared dx. Alright, after doing all of that math, you are eventually left with x to the 4th minus 2x squared plus 1 minus x minus 2 root x plus 1 dx. Clean up a little bit from here. From here, we can then go ahead and take our integral. Three over 2. Sorry, had a brain lapse there. X squared. From 0 to 1. The 0 you do not have to worry about. It'll cancel everything in here out. So what you are left with is, let me do some quick maths here. This 0 right here coming from that 0. Final answer 11 pi over 30 units. Alright, again, to save time, I just wrote down the formula that we're going to use here. So, find the surface area formed by rotating the graph of the curve y equals x squared from x equals 0 to x equals square root of 2 along the y-axis. Alright. So, I'm going to draw a little graph here. We're going to find our bounds real quick when we plug in 0. to here, we are left with 0, and then we have a 2. So these are going to be our bounds. We're also going to change this equation to g of x equals square root of y. You'll see why in a minute. And then from here, this is more or less looking like this. So we're doing a square root of x, but along the y-axis, right? And this is, again, just a rough sketch. This is going to be our square root of 2. So we have our integral from 0 to 2. We're rotating about the y-axis. This x right here is this x but the function. So we're going to be replacing the square root of y with this x. Okay? So 2 pi 0 to 2. I'm going to put this in brackets to make my life easier. 1 plus, so we need our square root of, I'm going to take the derivative of this function here, 1 over 2 root y. If we square that, we have 1 over 4 y, which is what we're going to put right here. So 1 over 4 y. Actually, we'll do 2y squared. Actually, no, it doesn't really matter. We'll just do it how it is. So we have our 4y. From here, we're going to move this bad boy in here. 2 pi from 0 to 2. Square root of y. You have the 1 plus 1/4 y, but we're just gonna do a little simplification here. 1 over 4 dy. Our u is going to equal y plus 1/4. Our u at 0 equals 1/4. Our u at 2 equals 9 over 4. So we're left with 2 pi 1 over 4 to 9 over 4 du. We can now take our integral, 2/3 u, 3 to the 2, 1 over 4, 9 over 4. So if we take our 2/3, plug in 9/4, 3, so 2 pi 9/4 minus 2 pi 13 over 6, 26 pi over 6. Let me just make sure I can't reduce that. Left with 13 pi over 3 units. And that is the answer to number 2. And thank you for watching. The next part of the video, we'll do question 3 and 4, and we will just continue to work our way through. So, see you at the next part.